All right. Good afternoon, if everybody can hear me. I am standing in for Ed Sitzler today to be the host of this presentation. My name is Jessica Winningham. I'm an interior designer for the Army Corps of Engineers at Huntsville Center and currently on rotation at headquarters. This is the Sustainability Webinar Series, and today we're going to learn about decarbonizing building materials, EPDs, or environmental product declarations, and pilot projects. At the end, we'll try to answer everybody's questions. But first, let me introduce the presenters today, Miss Alison Young and Miss Annette Stump. Miss Alison Young is a lead green associate, a research architect at the Engineer Research Development Center Construction Engineering Research Laboratory for the Army Corps of Engineers. She has worked on the source reduction and resource resilience team with a focus on recycling, composting, and waste reduction. The Cultural Resources team with a focus on incorporating digital technologies into preservation documentation, and the Sustainable Design and Development team with a focus on leadership in energy and environmental design, in policy and updates to sustainability guidance. Her current research efforts include the mitigation of GHG emissions for DoD construction materials and infrastructure project with a focus on environmental product declarations, life cycle assessment, and cost implications of utilizing sustainable materials in material construction to reduce and eliminate greenhouse gas emissions. And Ms. Annette Stump is a senior research architect in the USACE Engineer Research and Development Center Construction Engineering Research Laboratory in Champaign, Illinois. She has worked with G9, USACE, and Army installations to infuse sustainable technologies and practices into the Army's facility delivery process for new construction and renovation, and the planning, design, construction, and operation of installation facilities and infrastructure. Her primary research focus is identifying technologies and practices to transform the USACE design construction process to deliver Army and DoD facilities that are low embodied carbon, sustainable, resilient, net zero, and adaptable to climate change. Another research focus is to help installations plan electric vehicle charging infrastructure and adopt zero emissions grounds maintenance equipment. And now I'm going to turn it over to Miss Allie and Miss Annette. Again, we'll answer questions at the end of the presentation.
Hello, my name's Annette. I've been a soil researcher for a long time. I'm really excited to share this effort with you today. So we'll get going. Can everyone hear me?
Yes, we can hear you.
Okay. So first I'm going to cover policy. Why are we doing this? And I'm sure most of you have seen this slide. There's a new executive order 14057, and it's driving us to do net zero emission new construction, deep energy retrofits, and really focus on the materials that we put in the buildings too. So there's a lot of really bold challenges right now, and I'm sure we can do well. So the Army Climate Strategy, if you haven't seen this before, line of effort 1 installations, we're supposed to achieve 50% reduction in greenhouse gas emissions from all Army buildings by 2032 and attain net zero GHG emissions from Army installations by 2045. Now, this deals with electrification of facilities and reducing the energy used in the facilities, but it also deals with the Buy Clean policy, which is we're looking at materials, construction materials that have lower embodied carbon, and you've probably heard about this. And then there's going to be a big effort to focus on training so everybody can learn how to do this. So the Army Climate Strategy Implementation Plan so we're really working on developing a roadmap on how to incorporate sustainable building materials and engineering with nature tools and techniques in the MILCON planning and design processes, and to adopt the Army Buy Clean policy. The federal Buy Clean policy has 4 materials. They talk about concrete, asphalt, flat glass, and pavement. Wait, I missed one. Okay, so the reason I'm showing you this is because it's so exciting that all my career we've been focused on the energy part of the buildings, but now we're looking at that yellow spike on the left, the embodied carbon of the facility materials that and how we bring the materials to the site, how we build with them, what is the end life of it. Because in the past we were just focusing on the energy used during the operational energy used during the building life. And so I think this one picture, if you're going to try to explain this to somebody who hasn't heard about embodied carbon before, this one picture shows what we're talking about. The exciting part of this is it's such a big focus that we were able to develop a big research effort and get funding to actually get ERDIC researchers together to plan out a project to help the Army and the Corps and DoD actually figure out how to do this. How do we reduce embodied carbon of our materials? So right now there's several pilot projects going on. You've probably heard of the NGAA pilots. There's an example at the end of this briefing for the JBLM net zero pilot. There's some OSD pilots for net zero projects. There's a big effort to modernize all the guidance involved in this. Implement EPD, which is Environmental Product Declaration, and Allie's going to talk about that. We're looking at, this is research term, leveraging high TRL technologies. That's technology readiness level. That's something that's ready to go now. It's something that's been proven enough that we can incorporate it into our projects. And really figuring out how do we benchmark what we're doing, what are we doing now, and how do we get better, and how do we show that we've actually gotten better. So that's today's effort. In 5 years, we expect to be a lot farther along and be able to reduce the global warming potential of the materials and construction technologies we are using in our projects, and have a lot better guidance so everybody can do this easier with their jobs. And the pilot projects will be completed, so we'll see how well we actually did. I mean, then future on, there's always work to be done. So there's going to be a new generation of materials and guidance and net zero standards. How do we build these buildings that don't use any fossil fuels? So this is a big effort. And this project is a 4-year effort, and we have a lot of people involved. Allie's going to talk about more details, but we're able to work with our peers in the other ERDIC labs who are experts in concrete and asphalt and mass timber or bio-based products, so that we can really take the research in the materials and figure out how to translate it to something that we can use in the design and construction process. And this should also work for civil works projects or projects you have at an Army base or a military base. If you need to repair a building or replace pavement, we should be able to use these modernized specs to really reduce the carbon footprint. So Allie's going to talk about this part of it.
Yeah, so the project that we're involved in is the mitigation of greenhouse gas emissions for DoD construction materials and infrastructure. And there are 6 main tasks within this whole project. So the first task is primarily focused on the partnerships and stakeholder engagement. And this includes talking to the other services, other government agencies, academia, and industry. The second task is the lifecycle analytics, and I'm going to get into more of that in next slide. So we'll skip over that right now. Task 3 is focused on low greenhouse gas emission concrete. So promoting lower global warming potential concrete for inclusion in the UFCs and the specs, design concrete mixtures and products for lower global warming potential, and evaluating mixtures and products against the MILCON performance requirements. those are some of the tasks that they're looking at. Task 4 is bio-based materials. So this in a large part revolves around mass timber products, but it's not exclusive to that. And I just want to reference in September, the ECB 2023-14 was released, and the title of that is Mandatory Consideration of Mass Timber in Army Military Construction, or MILCON, and Civil Works Vertical Construction Projects. Task 5 is on sustainable asphalt materials. So some of the new approaches incorporate waste products or recycled plastics into waste, or recycled plastic waste and into the asphalt pavements. This can further mitigate the greenhouse gas emissions by diverting from landfills as well. There's also success in some technologies outside of MILCON, such as using more reclaimed asphalt, in-place pavement recycling, and preservation-based approaches to maintenance that could be adapted. And then task 6 is on modernizing guidance. As some of the individual tasks have alluded to, we expect that the research being done will provide opportunities for supporting information and guidance for updates in UFCs and the UFGS documents. Next slide. Next slide.
Sally, I know you got locked up there, but
okay.
We're on slide 11.
Okay. So task 2 is the lifecycle analytics. So primarily we're focused on LCAs, or the lifecycle assessment, which is evaluating the environmental impacts of the materials and products that we use in our buildings. It can be used for other things as well, but obviously we're focused right now on construction materials. So what we've been doing this past year with LCAs is just looking at all the tools that are out there. There's a lot of commercial off-the-shelf tools that are available, and we're trying to get as much information from them as possible at the moment. And we're doing an evaluation to determine which of these tools we're actually going to demonstrate in the next couple of years, with the purpose of trying to figure out what tools might be useful for Army and DoD use. So some of the criteria that we're looking at for the evaluation purposes are the user experience. So how much expertise will be needed to use these tools? Will it just be anybody, or do we have to have specially trained people to use these? The workflow or integration into current design processes. So does it integrate with BIM models, for example? We're looking at data quality. So what regions are covered? Is it industry recognized? Is there product-specific data? Is it possible to add or manipulate material information? We're also looking at the kinds of products that are produced. So especially for Army, does it cover the lead impact categories? And the methodology, so does it follow the ISO standards? So that's kind of what we're looking at specifically in the LCA realm. We're also looking at EPDs, or environmental product declarations, and we are very close to releasing a technical note on EPDs. We're currently in the final stages of editing on that right now. So we will let everybody know when that comes out. We're also looking at the lead credits revolving around these topics. So for lead V4 and V4.1, there are a handful of credits that we can be looking at. So there's a building lifecycle impact reduction, which looks at whole building lifecycle assessment. There's also building product disclosure and optimization for environmental product declarations. And there is a pilot credit for the procurement of low carbon construction materials. So we'll go into a little bit more information, I think, on a few of those a little bit later. The other thing that we're looking at is cost impacts. Just very briefly, we're trying to better understand at a general level, like the social cost of carbon and things like that that are kind of topics of conversation these days. So you can go on to the next slide. So I'm going to dive into EPDs now and just kind of give hopefully a decently thorough overview. So what is an EPD? An EPD is a disclosure document to communicate environmental impacts of a product. EPDs are developed by producers or manufacturers of the product. An EPD report typically addresses any number of common impact categories, some of which are shown here. The environmental impacts that are evaluated for a given EPD vary by product type. The impact categories shown here are examples from vinyl and ceramic flooring tiles, which include the global warming potential, which allows for comparisons of global warming impacts of different greenhouse gases. The primary energy, which is all direct or indirect energy used to transport or transform raw materials into products. Acidification potential, which is the potential to cause ocean acidification due to the uptake of CO2 from the atmosphere. Eutrophication potential, which is the potential to cause excess nutrient buildup in water bodies. Ozone depletion potential, which is the potential to cause depletion of the ozone layer. And photochem ozone creation potential, which is the potential to create smog. Next slide. So as mentioned before, as part of our methodology, we're looking at ISO standards that all of these follow. So here's a list of the ISO standards that establish the principles and frameworks in this area. Environmental labels and declarations fall in the ISO 14020 series. Specifically, ISO 14025 focuses on type 3 environmental declarations, which EPDs fall under. We're also going to discuss product category rules, which are developed under ISO 14027. And the 14040 series discusses the lifecycle assessment, or LCA, which is used to develop the type 3 environmental declarations. Next slide. So this slide shows the basic framework for creating EPDs. Product category rules inform the life cycle assessment, which provides information for the environmental product declaration report, which then gets registered or published as an EPD. So I'm going to go into further detail on each of these steps over the next 4 slides. Next slide. So here we have some important information and notes related to PCRs. First, what is a product category? A product category is a group of products that fulfill similar functions. And then product category rules are the rules and requirements and guidelines used in developing EPDs for those specific product categories. So product category rules define some of the LCA requirements, such as functional units, life cycle stages covered, which impact categories to report, and the verification procedures. Again, some of the related ISO standards include 14025 and 21930. Next, I want to mention the program operator, which creates product category rules. This can be an independent company, industry sector, or trade association, or a public agency. There's lists of PCRs that can be found at some of the websites that we've got provided here. Examples of the product categories that have PCRs include concrete, flat glass, gypsum panel products. These do have publications and expiration dates, so there is a renewal process for them as well. So breaking down the portion of creating an EPD here in the green box on the right, first, the product needs to be defined in a product category, and then we need to figure out find the applicable PCR or see if a program operator can create one. Next slide. So the second step in the overall framework is the LCA, or life cycle assessment. I want to be clear that the LCA is different from LCCA. So LCA, we're looking at the environmental impacts, and LCCA is more about the cost. So this lays out the 4 main steps for the life cycle assessment. The first step is defining the goal and scope, which the PCR helps to inform. Then the life cycle inventory analysis, or LCI. This can include inputs from the manufacturer, such as fuel and electricity consumed, raw material sources, and any information out of the control of the manufacturer, such as the electrical grid, which can be found in LCA databases. Then we have the life cycle impact assessment, or LCIA. There are many tools, software tools available for assessing or calculating the environmental impacts. So yeah, basically step 3 is doing the LCA. Next slide. So the LCA results and the PCR will help to inform the EPD report. And like I said, EPDs do have expiration dates. So we need to kind of pay attention to that. There are potentials for EPDs to become dynamic, which means that we can use EPDs as data sources for other LCAs, using more of the life cycle stages, such as cradle to grave, or in LCAs for other products. Next slide. Examples of, the final step then is registering the EPD. So we have to verify the LCA and EPD, and that can be completed by a third party or other program operator. The program operator is responsible for publishing the EPD. There's no standard procedure for how or where an EPD should be published. A variety of databases do exist, but there's not currently like a single comprehensive database. So some of the databases that we've identified are EC3, or the Embodied Carbon and Construction Calculator, the EPD Registry, which is a more global database with a focus on Europe and the UK, and Better Materials by USGBC and GBCI, which supports the search for environmental documentation needed to achieve the LEED materials and resources credits. EPA has been in the process of requesting information on how to proceed with further investigation and standardization of the EPD process. Okay, so some different types of EPDs. So there are industry-wide EPDs, which represent typical manufacturing impacts for a range of products for a group of manufacturers. These are not typically used for comparisons, but for whole averages or possibly benchmarking. Then we have product-specific EPDs, which can include manufacturer-specific EPDs. This represents a family of products produced by a single manufacturer. Product-specific EPDs that represent a specific product by a single manufacturer. And factory-specific EPDs, which represent a specific product produced at a single facility by a single manufacturer. So this graphic here shows that in 2021, there were nearly 60,000 product-specific EPDs in the US, which sounds like a lot, but when you think about how many products are out there, I think we've got a little ways to go. Next slide. So it's important for us to understand how these EPDs can be used. They can be used to understand environmental impacts, obviously, so used as a data source. Ideally, we want to be able to use EPDs for comparing. Not all EPDs can be compared to each other, though. EPDs must follow the same PCR to be considered for comparison. And even then, there might be some issues comparing across those EPDs, depending on other factors, such as the quality and consistency of the data inputs. And then the other thing with comparing is ideally, if we can't compare EPDs to each other, is there a way to compare to baselines? There are some issues with that I think I'll get to in a few minutes, but that's another option that we're looking at. And then finally, for LEED or third-party certification. Next slide. So getting a little bit further into looking at the LEED credits, LEED has a credit for conducting whole building lifecycle assessment. This looks beyond one product at the system of products in a building. This can specifically look at structure and envelope. More closely related to our topic today is the Building Product Disclosure and Optimization Environmental Product Declarations credit. This credit requires multiple products from multiple manufacturers with EPDs. These EPDs can be used for products with publicly available, critically reviewed LCAs conforming to ISO 14044, products with product-specific Type 3 EPDs that have been internally reviewed, products with an industry-wide Type 3 EPD, and products with product-specific Type 3 EPDs that have been third-party certified, which those are the best. They're worth a little bit more in points. The pilot credit for procurement of low-carbon construction materials requires a baseline calculation and a secondary calculation showing the reduction in embodied carbon intensity by using lower embodied carbon materials. So you can obviously look at USGBC's website to get into a little bit more detail on these credits. Next slide. So looking at some of the challenges and gaps with EPDs, right now there's a lack of standardization in how EPDs are created, formatted, and verified. So there's not a lot of regulation in PCRs and EPDs. EPDs are complex in how they're created and how they're accessed and used. So sometimes they're discussed as a nutrition label for products, but they're much more complex and difficult to understand than that. I discussed the EPD uses earlier. We talked a little bit about baselines, but baselines are still in the process of being established, and EPDs aren't consistent enough yet to be reliably comparable. Also, many products still don't have EPDs yet. The first step in documenting and understanding where we are with materials. Finally, what will be the impacts of requiring EPDs and target goals on the design and construction process? The development of EPDs is not free. It does cost money, and it will take time to implement and integrate the collection and use of EPDs in our processes. Next slide. So we wanted to show some examples. There are some states that are currently implementing some Buy Clean acts. So I just wanted to highlight a few that are already working in this area. California has the Buy Clean California Act from 2017. This bill targets the reduction of greenhouse gas emissions based on product purchases for state public works projects. EPDs required for structural steel, concrete, reinforcing steel, flat glass, and mineral wool board insulation. They do have maximum acceptable global warming potential limits for these materials, and they require single facility EPDs for compliance. EPDs right now are not required for concrete and mass timber. Colorado has the Buy Clean Colorado policy from 2021. This bill targets the reduction of greenhouse gas emissions and climate change impacts. The eligible materials that they call out are asphalt and asphalt mixtures, cement and cement mixtures, glass, post-tension steel, reinforcing steel, structural steel, and wood structure elements. So EPDs are currently being collected and they will eventually be used to create benchmarks for future requirements. And then Oregon has the Buy Clean Oregon Act from 2022, and that law targets greenhouse gas emissions within the State Department of Transportation. And basically they're calling for a program for greenhouse gas reduction to be established by 2025. Next slide. So finally, we kind of want to wrap up with looking at progress amongst other federal agencies. So the Federal Highway Administration has been working in this area for a while. They've kind of laid out a plan or roadmap for using EPDs. So the first stage is basically just requesting EPDs, utilizing incentives and pilot credits to create a database. Step 2 would be the standardization of the PCRs. And then stage 3 is utilizing EPDs in procurement and design. The EPA is working with the public and industry on how to advance, expand, and close gaps in this process. So they've been holding public webinars and engaging the public for feedback. GSA has also been working in this area. They've got some pilot projects that are currently in progress, and they've been working on standards for low embodied carbon concrete and environmentally preferable asphalt. Next slide.
Hi, I'm back. So the NDAA pilot project that we have an example for is the one that Seattle District is doing at Joint Base Lewis McChord. I've put all the slides in the current official version of the report. I'm not going to go through all the details. You can look at the slides in more detail yourself. But this project, they were surprised with it at about 35% design, as I understand, and told to make it lower carbon, embodied carbon. So you can see this elevation. The other project before it was 100% brick on the exterior. They got a waiver from the installation design standard to put panels in to reduce the brick. So we know concrete is the highest polluting material. Other masonry, steel, wood is supposedly better if you can use that in the right application. So the team did a great job. I'm really impressed with them. So they were told to try to use sustainable materials as a primary construction material. There was a process where a lot of project sites were evaluated because we were looking for a project that was vulnerable to extreme weather. So we looked in the DCAT Defense Climate Analysis Assessment tool to figure out the characteristics of all the projects. And somehow this one was picked. So they worked really hard to just rethink how they were doing the materials for the project. And I have to mention structural engineers are pretty much key to all this because a lot of the big materials are in the structures. So there's been a consistent tri-service coordination effort because there's other pilot projects. So there's weekly calls. Everybody's involved in this. It's a very interesting process. And ERDIC is supporting these projects with the technical expertise. So this is the exterior elevations for the project. 168 soldiers, 2 3-story barracks, 40-year life, and they want to get LEED v 4.0 silver. So they got that waiver to add brick panels, or not with metal panels. And the exterior wall construction is light gauge steel stud framing with wood shear panels. Upper floors will be concrete over metal, decks spanning between bearing walls. So once you start looking around for lower carbon materials, there's a lot of training materials and examples you can look at. And actually, Portland and Seattle is a hotbed for great sustainable materials. They're doing a great job out there. So they were able to, with the ERDIC team and everybody working together, they modified 9 specs to make the materials more sustainable. They're looking at EPDs, emissions, performance requirements. You know, you want a material that actually is resilient, is going to last, it's durable, it performs well. You don't want to just pick a material that's lower carbon that's not going to work for your project. So you have to really evaluate those. And you have to look at the cost and other submittals, you know, delivery. That all has to work with your project. So there's an effort now to update or suggest updates to UFGSs. And they used the Carbon Leadership Forum 2021 materials baseline as low emission targets. So the concrete and steel, you can see details here. So the concrete, they're looking at 50% better than the baseline. A baseline is average concrete you can get. Trying to get 40% better than the GSA standards, 30% better than the Carbon Leadership Forum, low targets. There's a lot of targets we're looking at. The steel, they got 25% better than baseline steel and 10 to 30% better than the Carbon Leadership Forum, low targets. So they looked at the wall sections. They reduced the wall, the emissions of the brick by reducing the quantity by 30%. And they looked at the insulation too. So all these specs were modified. And they did a lot of work with the integrated planning and design process. And these are all the details of how they complied with the UFC, the high performance sustainable building requirements. I'm not going to go through all these. They're looking at all the LEED credits, of course. Gold achieved LEED silver. And the schedule, they're on schedule. If I remember correctly, there's probably someone on the call that's part of this project. I think they put the project out for bids and they've received some bids, but that's where they are right now. So they've done a good job of staying on schedule too. And this is a very high visibility project, as you can imagine. So we went through this kind of quickly. We have some questions. I know you have questions too, but we're really looking to hear from people that have tried to earn the LEED LCA credits or the EPD credits. Have you tried to do a life cycle assessment? Have you used Athena or any of the other tools? Have you collected any EPDs? Our names are on the next slide so that you could send us information. We're happy to talk to you. We want to hear your problems, your successes, because we're trying to figure out how to make this work for the Corps. Now, how do we make this process that's right now pretty cumbersome? How do we make this actually work? So I'm done. Allie, do you have any more to say, or should we just open up for questions?
I think we can open it up for questions. Do you want to go to the next slide so we show our...
This is us. And there's a bunch of our team members on the call too. This is a big project with a lot of people on it. It's a fun team.
There are a couple of questions in the chat. The first one is, are some of these materials proprietary or is along the lines of quote unquote green steel, where the focus is not on the steel, but a foundry's source energy?
I think the green steel is a good example. It's, they're using less energy to produce the steel, which is what we're trying to do. Remember that yellow bar that was way up? How much energy is used to create the product? So I think somebody told me the pilot project, they found wind-powered steel or something. But
I would imagine that the answer to that is probably a little bit of both. I think it kind of depends on what the product is. But obviously, energy in the manufacturing process can be a huge part of that global warming potential. So if we're able to reduce that or use renewable energy, obviously that would help to decrease that global warming potential, which seems to be the focus of a lot of the goals and targets right now.
We were talking to the Council of Environmental Quality and the EPA, and they said just in the process of them working with companies to try to figure out what is an EPD? How do you create one? The companies realized there's ways to make their business process more efficient, to use less energy. They just hadn't really thought about it. So we're not trying to be proprietary in general. Next question.
I think Mr. Daniel Edwards has his hand raised. We'll go there, and then we'll go back to the questions in the chat.
That was just to clarify. The question was just to make sure that, like, if there was, like, say, only one game in town, that, you know, if somehow there's some exception in the FAR where, you know, like, this way we didn't have to go through like J&A if it's like, hey, you know, here's a priority administration, so you have to use this product, kind of a thing. I just want to make sure that if there are like, hey, look, we can get green whatever or low carbon this, that you know, we don't get in a pickle with procurement. That's all.
That would be good to write down and send to us, and we could send it to Ed. That's a good question.
I do want to kind of elaborate too. This is a little bit of a tangent from what you're asking and saying, but EPDs are really just another tool to be used in this process. And so something that I've been trying to emphasize whenever I talk about them is the fact that just because we have an EPD doesn't necessarily mean that like that's the right product for us to use. It's definitely going to still require our expertise, our subject matter experts for architects and designers and engineers to assess and make sure that we're still meeting all of the other qualifications that we need to meet, whether it's the strength of the product or the longevity of the product or the finish or whatever that is. Oh, apparently my light just went out. So it's just because we've got an EPD and maybe, you know, EPD A is less than EPD B doesn't mean that that's necessarily the product that we need to be going with. We need to really still take it into consideration with all of the other factors that we would have to take into consideration for the selection of any other product. So I want to emphasize that because that is something that I guess I didn't have specifically stated in the slides, but it is an important thing for us to, I think, understand is that it's just another tool that we have to use.
Okay, and I see another raised hand, Miss Sheila Pasoza. Sorry if I mispronounced your last name.
It's fine. Everybody, nobody knows it.
Sheila.
Hi guys. Hi Annette. Hi Allie.
Hi.
Sorry I didn't see you last week, Annette, but got to see you, Allie. Excellent presentation. When I called into this, I was like, what is we were going to talk about? One of my questions is, you know, it sounds like we got some bids on the project. They're probably doing evaluation, source selection. You know, did we have? One question is, were there a lot of comments raised during bidding, you know, about some of these things? Because I'm guessing they looked at that lead scorecard and they were probably like, oh wow, this is a lot of stuff to do. And so I don't know if you guys know any of that. If you know if there were comments or concerns about it during the bidding process. Over.
Is there someone from Seattle District on the call that could answer that?
I don't know.
I don't know.
I don't know.
I was going to say I'm Sven, and I'm in the NWS district, but I cannot answer that. I don't know the answer to that question.
Okay. Well, I'll send it to you guys I'm just thinking as, when I was in construction in Kansas City, this puts a lot on the contractor and then construction to make sure that we get this done right. And, this is going to be, a lot more documents that are going to have to, I'm expecting more documents that have to be reviewed and validated. And so it'd be, when they have that pre-construction meeting, I think it'd be helpful to highlight this in a pre-construction meeting with the contractors so that they know that this is number one, they're going to, hopefully they'll know it's a high profile project, but number two is know that what we're looking at. So I don't know when the pre-con meeting is, but I think it'd be helpful to have a presentation, something like this, to talk about what they need to be looking for and asking for when they're suppliers.
So you have to remember Seattle's in the hotbed of progressive people and materials and the living building challenges out there, and University of Washington, I think, started Carbon Leadership Forum. So there's proven cases out there that other people have built. So the specs that ERDIC worked with the Seattle district team on, there's nothing there that's super difficult. It's all achievable. So they worked really hard to just tweak the specs and make this achievable. But that's not every part of the country. You're right.
Right. And, I think that they're going to have challenges, they might have challenges anyway, even though their contractor, the general and the team is familiar with it. But, I think it's worth bringing it up and, making sure that the sustainable manual is reviewed as it's supposed to be per the spec.
Right.
Up to date over. Cause,
right.
And any lessons learned from, related to the specs, related to construction admin, I think would be appreciated. Over. Thank you so much.
Yep. This is part of change. We have to do it. So the concrete industry has been working really hard to get cleaner because they were marked as the worst material ever. So they're like, the whole industry is trying to change and get cleaner concrete. And our researchers know a lot about the different recipes for concrete and when it applies. So there's an effort to start changing the specs now. So next question.
Looks like we have a hand raised from Mr. Dan Byrne.
Hi, so I'm from the Fort Worth district, the mechanical section, but yeah, I've got some things that they were a little too complicated for a post. So the first thing I would say is that it kind of looks like to me that y'all's plan is a little disconnected from your goals. You guys had identified that your goal was to reduce embedded greenhouse gas emissions by 50% by 2032. But the first thing you have to do before you can reduce anything is find out where your benchmark is. Where your greenhouse gas is coming from, how do an inventory of what's being produced, and I didn't see y'all talk about that at all. So I don't see that we know where we are. How can we reduce from something where we don't know where we are? So and if you're talking about the EPDs and the different materials, and that's fine, but if you've got one material like a caulking that you can reduce 75% of the greenhouse embedded emissions, and you impose compliance with that better caulking, but it's actually your concrete or whatever that is producing the majority of your greenhouse gas emissions, it doesn't make much sense to put a lot of effort into getting your caulking to be really low emissions when that's got a very low impact on what your goal is.
You're
And then
right.
all,
We have to do the big ticket items, the most important, the biggest carbon emitters, and a lot of that is structure and envelope. That's kind of where we start with. And we talked about the benchmark for that JBLM project. Should it be the building they built last time, or should it be the Carbon Leadership Forum's? They've got a 2021 benchmark that people are using. GSA's using that. So they've looked at national level data for different materials. Not all the materials, but the big structural materials, the big emitters. And that's kind of the emerging benchmark. And then they have a newer generation one.
yeah, I didn't see any numbers. Y'all didn't talk about any numbers.
No.
And then also when y'all are talking about goals, are you talking about goals on individual buildings or entire construction streams? And you know what is the what is the benchmark? So I think that I would have liked to have seen more information on that.
Okay.
And then also on the EPDs, you've got the goal of reduction of embodied greenhouse gas emissions, which is fine. But then y'all start talking about ozone emissions, all these other different things. Somebody submitted a a question about EPDs that cover whale kills. So how do we get from greenhouse gas emissions to whale kills? So if you're going to have a goal, then I think trying to narrow your focus on that goal and not get, try to put your blinders on, you can get caught into so many different things. And that's just going to eat up all your resources and your time and make it very difficult to achieve your primary goal.
So I think our goal, the big picture goal, is to figure out how to do this, right?
No, I think first you have to figure out what your benchmark is. And then once you figure out your benchmark, then you can identify what your goal is. And then
Well,
once you
you can
identify,
imagine, we've been studying this for a year and it's complicated.
I
I'll say this.
understand, but
So
like I said, I
kind of
don't see any numbers. I don't know where you are. I don't see what your benchmark is.
we're presenting a lot of information that is kind of across the industry. So industry is working on figuring a lot of this stuff out as we go as well. Part of it, I think your benchmarking question has to do with, I think there's different things that are called out in like the executive order and in like the Army climate strategy and things. They're calling out different benchmarks from different years and things like that. And it's hard for us to know what the embodied carbon of certain materials were from 2008 or 2005. So I think a lot of what's going on, Annette referenced the Carbon Leadership Forum's baseline that they're trying to figure out. So as EPDs are being created for materials and products that are out there today, whether or not they're quote unquote more sustainable or if they're just, whatever products out there, they're trying to take, what data they're getting as these EPDs are created and create baselines. I believe what they're doing is creating baselines from the information that they're getting. And that's what's difficult is that, as we were talking about how specific these EPDs can get, is it can be down to the specific products from a specific facility, from a specific manufacturer, or there can also be very generalized industry-wide. So finding a baseline is difficult. And that's what we're trying to look at through this process of, you know, how do we just compare to these industry baselines that are maybe starting to be established, or are we looking at, you know, Annette made an example of, you know, do we look at another, you know, Army barracks that would have been built otherwise with different materials and different quantities of those materials. So we are having a lot of those discussions and trying to figure a lot of that out as we're going through this process. I feel like there was something else I was going to touch on with all of this as well. If I think
all
of it
the
all.
different, I forgot the right word. You know, like the LEED credit, they've got 6 or 7 different data. What is they're looking at? That's, you have to do that for the LEED credit, right?
Yeah, so when you're talking about the impact categories beyond global warming potential, some of that, basically a lot of that is coming from these LCA tools. They're providing this information for all these different categories based on the inputs for the different materials and quantities that you provided. And each tool is different and each tool uses different databases, but a lot of times they come up with those impact categories. So we're not just randomly coming up with these, and we're not randomly choosing these or saying we should have all this information. A lot of the information that we're getting from like the executive orders and Army climate strategy and things like that are focused right now on that global warming potential, on the embodied carbon, for example, in the material. I think the way that these tools and LEED and everyone kind of looks at all the other impact categories is at some point we might also want to take into consideration these other things, or we should be taking into consideration these other things. And so how do you find the right balance that you want in selecting the right material using that kind of information that you're given from these tools, whether it's the EPDs or just going through the whole LCA process? So hopefully that helps. We're not just doing a bunch of extra work to get that information. It comes out in the same report with everything else, with that global warming potential.
And your question's a perfect example of why we needed a research project to figure this out before somebody makes you do it. Because we're trying to figure it out, understand it, be able to explain it simply, and then figure out some method or process where a team could actually do this. But there are teams out there, if you start reading about this, there's, you know, USGBC, there's LEED projects. I heard like 4 years ago, 2 structural engineers talk about doing this with their projects. You know, picking the more sustainable materials and reducing the GHG emissions for their projects. So there's a lot of people working on this. It's just difficult.
Okay, so if I can just walk through this real quick. So we establish a benchmark, and then we establish the goals, and then we establish the things that we want to do to move from where we are to where we want to be. And then how do we disseminate that information? Are y'all going to generate more ECBs or change the UFCs, or how
Yeah,
are we
yeah,
going to
we're working on that. So there's the first step, I think, is to, well, we've got the tech note coming on EPDs. And there's going to be some changes to the UFCS, the criteria, the specs, the known stuff that can be changed. There are teams working on that. I don't know. So
we're also looking at it in terms of short-term and long-term goals for some of those changes. As Annette just identified, there are some things that our research team has been identifying that maybe industry is already doing. It's, you know, maybe a little bit more common, and we just haven't integrated it into our systems yet. So those are probably more near-term changes that can be made, or you know, suggestions that can be used in projects. But then we're also looking at long-term things. So the integration of, you know, doing the LCAs and really fully integrating, you know, how we're going to use these EPDs and lots of other topics as well, that they're hot topics right now. Industry is also working on them, but it's going to take a few more years to really get to the point where we can have that solid information that you're asking for right now to fully integrate it into our processes.
And if you're working on the building envelope, you have to meet the ASHRAE requirements. So maybe the materials you pick on the envelope and the insulations, different global warming potentials for those. I mean, those are things you can do now. So
Sure.
there's,
So
so
we've
you have
got
to just choose what you can that makes a difference, because we all need to get started and make a difference now. It's game on.
Yeah, but
So
we've got an executive order, so we in 2032, and whatever president we have in office then, he comes back and says, well, how did you show me how you accomplished this previous executive order? So I was just wondering, who's going to be tracking that, and how is that information going to be presented to Congress that that we are complying with it?
Oh, we have reports to Congress. Don't you worry.
All right.
And everybody's reviewing them, and they go all the way up for those pilot projects. There's serious reporting to Congress. And,
All right.
there's also a competition with GSA and the other agencies, right?
Sure.
So they're doing stuff already. We got to get on the game. And I think we're doing a good job. Okay.
Sorry, it is 4 o'clock, so we'll answer the rest of the questions. I've taken note of them, and we will try to get those answered and get those back out to everyone. The slides are in the Sustainable Teams channel, if you have access to that. If you don't, please, I think there's a way, I believe you contact Ed Sitzler. Otherwise, it's in the meeting invite, the instructions. And then our last sustainable webinar is next week, November 9th at 1400 Eastern time. And it's the introduction to deep energy retrofits. So hope you all can join us, and thank you so much to Annette and Allie for presenting today.
Thanks everyone for asking questions. That's good too.